Hey, it's W5HRO. Well, I'm in the process of debugging this thing. I've ran into a couple other problems. The first problem is I've been getting that 120 hertz, and I've determined it's probably the rectification from the DC supply that's somehow getting into these transformers. And this transformer here, if you look at this, the yellow, see it's 120 hertz, 119, 120 hertz. The yellow one is the output of the actual, driver, the whole thing after it goes, after the 6AS7, it goes through the output transformer through this load that I'm looking at. I got a high voltage probe now. This is a 2000 volt, 100 to 1 probe. And I can look at that, and I checked the DC ripple on the supply on the 350 volt and it's clean. But that's, I'm seeing 120 hertz on this thing. And I've turned everything off here in the shack, and there's nothing here on the bench. It's something in there. And I think I may know what it is. Yesterday, it was real bad. What I'm looking at right now, where's the schematic here? Ignore the red markings on this. I've been looking at the grids. Like right now I've got this scope probe, and I just had my ×10 probe on here, and I was seeing it real bad. It was pretty strong yesterday just on the blue traces, which is what that scope probe is going to. There on the bottom, it's the same shape. It was just a lot stronger. And overall I was getting like 90 volts peak to peak out of this thing because of all that going through, getting amplified. So I found out, I went ahead and thought, maybe it's the placement of this little transformer. So I pulled it out, and as soon as I moved it away from these two rheostats, it went away. But today I came out, okay, I went ahead and I remounted this yesterday. I thought I'd come out here and I'd wire it up today because I've been thinking what I've been doing here. I've been going back, kind of like, well, is that the way I really want to do it, and so on. I've been kind of second guessing myself to kind of make sure that this is what I want to do. And I discovered something else, but I was looking at this, and as soon as I pulled that transformer away, it went down and went away. Well, today, after I remounted this thing and I've wired it up, I thought it was gone. I didn't see it on the scope, right? I went, wait a minute, let me go to ×1. And I went to ×1, and it was still there. And I'm seeing like 130 some, 120, 130 some millivolts is what I'm seeing. I just wasn't seeing it on the ×10 scale on the probe. So there it is. It's still there. And see, it's getting amplified through. So let me go ahead and let's power this thing off for a little bit. And I have to let what I've already done it, and I've already verified that I'm still seeing a little bit on the output stage too. And I'm seeing, I've got that load across the output of this transformer is what I've done. So let me see this tube, it takes a while for this to cool off. These tubes are hot. So let me see if I can get in here. Let me go ahead and stop the video, then we'll go ahead and splice her. Okay, now I have the 6N7 tube removed, but you see how it's on the transformer? I'm looking at the grid of this tube right here. I'm sorry, the grid of this, I don't know which grid it is, pin 5 or pin 4 here on the 6N7, but I'm looking at one, it's pin 4, I think. Yeah, I'm looking at pin 4. So I'm looking at this one, and the tube's pulled out. So I'm just looking at the output of this. I don't forget this I'll explain this in a minute. This isn't there right now. It's just directly wired to the grid from the secondary. So I'm looking at this with the tube removed, and it's still there. I'm seeing 94. But see how the one on the output went away? Now, let me move the scope probe over to the grid of one of the grids of the 6AS7. Let me see if I can clip this. And I'm also on ×1 here. So let me do a resyncing of this thing here. Wait a minute here. Let me turn channel 1 off and is that the right one? Or am I on there it is, see? It's actually on the 6AS7. It's probably on the transformer. It's probably on the darn transformer. So what I'm going to do next is I'm going to pull I'm going to put the 6N7 back in, but I'm going to remove the 6AS7. But see, that's still there. See, 120 hertz. See it? And there's 100 and some millivolts on the 6AS7. It's on the grid, not on the output, but I'm looking right now. I'm looking at the grid. Which one am I on? I'm on pin 1. I'm on pin 1. So that's the one. I'm on the grid of this 6AS7. And I bet if I pull that tube out, it's still on the secondary of this transformer. So let's stop it, and I'll do a splice with this one too. Okay, I went ahead and I pulled all the tubes out of this thing. They're all pulled out, and I'm still on that same pin 1 of that 6AS7 grid pin. And I'm still seeing the 120 hertz. Look at that. It's on the transformers. You know, I've moved the wires around, I've done this and I've done that, and it's on the transformers. And I think I may know what it is, especially this one here, but I'm seeing it. Well, I'd have to unhook I'd have to disconnect this transformer, this 124B, from everything, unhook all the wires. I just retacked it in there. I had to make the red wire longer because I'd cut it shorter to reach where it needed to be, where it was mounted. So, and I touched these wires and it's not doing anything. So you know what I'm going to do next? I'm going to unscrew the screws so where I can kind of pull these away from the bottom of the chassis a little bit and see what happens. But I found out, at least on this 124B, the primary of this transformer is not supposed to have any DC current on it. And it's not. And the problem is it's on the transformers. It's on both of them. And there's no connection from the primary of this 124E over here from this one to this one with the tubes removed. So with the tubes removed, everything's isolated. So, and it's still there. So I'm going to come over here and I'm going to look on the, back on the grid of this, let's see if it's over here. I'm sure it's over here too. It's got to be. I'm going to wind up shocking myself, and I'm going to draw an arc one of these days. Oh, there it is. It's on the grid. See the first? See, it's on the transformers. It's getting on the transformers. And I think what it is, since these transformers don't have a DC gap, you have to couple over to the primaries. So I'm going to do one or two things. I'm going to do that now. I'm going to try it, although it's going to be But I think it's the DC. There's enough of that 120. And I took that scope probe, the high voltage scope probe, and I've already analyzed everything. I'm not seeing that the DC is clean. It's just that there's enough common mode that it's probably getting on. It's coming through, and this transformers is actually amplifying it somehow. It's getting induced on these transformers. So that's what I've got to look at. It's the switching action of having these two dials and having a full wave center tap grounded supply. You get the 120 hertz because of the way the thing works. And the DC line is clean. I mean, it's clean. I went ahead and I've got a couple 100 mic caps, and I went ahead and I took a short jumper lead and I touched them to ground, and I touched the positive leads to the supply lead, and it didn't change it at all. The supplies as filtered as it could be for this application. So it's just getting in there. It's getting induced, and I think it's getting induced onto the primaries. So I think I may have to, either I've got to eliminate these transformers and just RC couple the whole thing, which I can do. I can make it work. I really don't want to do that. But I'm thinking, what do I want to do now? Do I want to go ahead and unloosen these screws first and pull these things away from the tube sockets to see if it goes away? It might. It could be the position of these guys. I don't. This one shouldn't be a problem, but it's probably because you're not supposed to have DC. This one I know you're not. This one is question mark. I've read things where it says you don't put DC on any of these things. So what I'm thinking is, on the 6SK7, I could do this. I could do the 100K resistor back like I had it, which will make that resistor a lot smaller. And I just cap couple it with like maybe a 2 mic cap, 3 mic cap over to here, and you ground the one end of it. And then this is the 6N7 over here. I could do that. And the other thing I could also do, they say it's a good idea, you can actually cap couple these guys over with the same, similar size caps. Then what you do is, I can just put the 470K, grid link resistors on both sides, so the tube's happy. You can also do that, see? You can do that. So I can completely remove DC off both sides. This one's usually not a problem, I don't think, on the secondary side, unless you've got an imbalance. If you've got an imbalance, that can cause the problem. But with no tubes here, what's happening is that is just getting amplified when the tubes are plugged in. That's all that's happening. It's getting amplified, and it's probably getting in, on the primaries, I'm thinking. Now here's the thing, the main issue with this speech amp driver is I've tried to revise this thing and do a retrofit to the existing layout where everything was arranged on it. What I really should do is I should just go ahead and buy one of these new chassis and just redo it and redo my layout. That's part of my problem too, but I think if I can make it work with these two, I'm just trying to get this thing to work, to get that out of there so I can make this thing work. And my plan is I am going to buy another one of these. And when I have time, I'm going to rebuild it again with the layout like I want, Basically, when I'm looking, like, see the 6SJ7 here and then the 6SK7 socket, this is the bottom of the rack when it's mounted in there vertical, and this is the bottom of the. If I'm looking in there in the thing, see I've got the square rectangle, the 6SJ7's there, and the 6SK7's there, and then you have to go way up over here to get to the 6N7 and the 6AS7, and that's what I don't like. What I want to do is, like the inside of the chassis, if you're looking on the inside, say I've rotated this and this was on the bottom here, this side here was on the table, it was flipped over around, that socket would be down here. I'd have the 6SJ7, the 6K7, the 6N7, and the 6. What I would do is I would space them all out right in a row and have the power supply stuff on top, which is what I know now why I put those two tubes on top. This wasn't the chassis that I was thinking of. The reason I did this way, because these two connectors are right above where the RCA jack's on the 810 modulator rack, the final rack. And I'd had the tubes right here because I thought I might put that KW1 driver transformer right there. And I wasn't sure at the time, and I built this first, and I thought, well, if I'm going to put that there, I want everything sort of like in order, like it's going this way, then this way, and coming down, to these RCA jacks going to the modulator rack, going to the 810 rack. And I put them up there, and I remembered now that's why I did that. Otherwise, I would have put them all in a row down on the bottom. I would have had the 6SJ7, the 6N7 phase inverter going right to the pair of 6A3s, one here and one. I would have had them all right in a row. And that's what I'm going to do if I redo this. And not only that, I'm not going to get a power transformer. I'll order one of those Hammonds, like one that's probably just a hair bit higher voltage, maybe like 200 mils. And then I'll use a separate 12 volt transformer, the right current, and or not 12 volts, but a 6 volt. I'm going to actually make a 6 volt DC supply, filtered supply for the filaments. I'm going to convert them to DC. That eliminates that problem. But I'm just, I don't think, because it's actually on both of these guys. See, that's where it is. It's on both of these guys. And there's no tubes plugged in. It's on the secondaries. It's hard to see on the primaries, but you can see I got the 100 to 1 probe now. And it's clean as a whistle. It's just, there's just enough there barely to see it. I mean, it's like 48 millivolts there on the one, right on the first one. So it's like 48 millivolts right here. But do I want to try coupling these transformers first to see what happens, or do I want to go ahead and unloose them and pull them away from the chassis to see if that does anything? And if it does, what am I going to do? I mean, that's where they have to go. I mean, I don't know what I would do. How are you going to solve the problem, right? I mean, there's not much you can do. I mean, they have to be there. I'd have to get a new chassis and relay everything out. So, but I do want to do that eventually. I was hoping I could just get this working for a couple years, or, then I'll just buy another one of these and I'll rebuild it when I have time, and I'll just construct a new one. I was hoping I could figure it out with this one, then I could improve and redo the layout after I figure it out first. So that's what I'm trying to do. I never thought in a million years this would be that hard to retrofit and modify, because all I wanted to do was put that compression, that 6SK7 compression tube in there also for the AVC limit, and you switch to the 6AS7 because it's a single tube. This tube is more durable than the 6A3s are, way more durable. So anyway, so I guess that's it for now. I'm still plugging away, so let me see what I got to do, because if I can't get rid of that, this thing's not usable, and I may have to just buy another chassis and rebuild the thing before I can use it. That's like a several month, and that's going to take me, part of the summer to do. If I have to, I will. I hate to do it, but it's like whatever it takes to get this thing done. I never thought it would take this long. I mean, I finally got 350 volts peak to peak coming out of this thing like I never had before. And I think the reason when I got it up real high and you saw it was the kind of distortion on top of the waveform, I think it's just this crap getting into it that's mixing in with it. That's probably what it was. When I get rid of this problem, that, it's going to probably eliminate that too. So, let's see. Do I want to RC couple everything, or do I want to try this scheme first and see? What I might do is I might go ahead and cap couple this one. Let me go ahead. I'm probably going to do that. I'm going to put the 100K plate resistor in series with this. I'll have to change the cap. I could just parallel. I could probably take if I take an alligator clip to get long leads, I might pick up that noise, but I could try it temporarily. I could just tack another resistor across the one I have in. Well, no, it's going to have to be a larger resistor. Oh no, I've got an 800. I got an 8.2K. It would have to be smaller. To show you what I have on this thing now. Where is it here? Yeah, see, I've got an 8.2K, and I was going to go up to a 9.1 before it was over to get the right, because I've got like 5.8 mils flowing through this thing now, which is what's in the winding. But I think I'm going to have to remove the DC off these transformers. That may be what's happening, because it's getting induced. It's just making it happen. You know what I'm going to do? For the heck of it, I'm going to unsolder this black wire. I'm going to power it off the center tap of this first transformer and remove it from ground. And I want to see if it's still there. I want to see if it's getting in via the ground, because that'll tell me a lot if it is. So that's all for now. I'll be plugging away with this thing when I have another update, if I can figure this thing out. If not, I'm going to have to remove these two transformers, and I'm going to have to try to RC couple everything. And then eventually, like I said, I'll get another chassis and I'll redo layout. I'm going to do that anyway, because I hate the way I've got this. I want all those tubes right in a row. So basically what I'll have is, if you're looking at the, say you're looking at this side of it, right? This side of it, the top side of it, and you're looking from the back of the transmitter, and you're looking at it. What it'll be is the The 6SJ7 will be here. The 6SK7 will be there. The 6N7 or 6SN7 will be there. And the 6AS7 will be there. Then I'll have the plate transformer here. Or should I put it on this end? I might put the plate transformer there. Oh no, because I've got, yeah, it won't matter. But I'll put plate transformer there, you know, the filament transformer for the filaments, and then it'll be a DC supply. And then I can put the well, I'll put them on the bottom side. On the other side, I'll put some big 100 mic 600 volt electrolytics, which I do have. And I'll filter this supply just as good as I have it now. But see, that's what I would do. I'd have a separate, not only that way too, I can put one of those delay modules in there, those little timer boards. So when the thing powers up, the filaments come on for at least, 30 seconds before the plate transformer kicks in, like I did on my T368 exciter rack. That would also be a good thing to put on this. Wait to apply the high V before wait till after the tube filaments are warmed up. So, but that's why I want a separate filament transformer. So that's what I would do. I'd use a separate plate transformer and a separate filament transformer, and I would convert it to DC. So I'd just take a 12.6 volt center tap transformer and ground the center tap and make a DC supply at 6.3 volt DC supply out of it. That's what I would do. And I would power up all the tubes with that DC, and that eliminates any 60 cycle ripple that could get multiplied or doubled in the 120. But I'm pretty sure it's because of the diode rectification and the full wave center tap. So I'm going to go ahead right now and I'm going to pull this black wire off next and see what that does. Float that center tap and see if it goes away. And if it does, well, I'll just wait and upload a video the next time when I go to do another one, after I figure all that out. So 73s for now. This is W5HRO.